Very good morning, friends. Till now we have studied about soil erosion, its control measures, and also the land capability classification. There happened a term contour, like contour mapping, contour bunds, contour farming. So what are these contours? Even in this our course curriculum, there is a separate chapter for as contour and study of contour maps. Today we will be dealing with contour maps or contouring, and also we will be trying to find what are the properties of contour lines and uses of contour lines, and if time permits we will do some exercises on calculation uses of contour map or a topographic map in a classroom study. Talking about contours, first we have to understand what are plan and a map, and also scale. What is a scale? Scale is the ratio of that every point in a map represents the corresponding points on the ground. In every map you see on the left side, in the left bottom side, you see the scale of the map. It is written as 1:500 or 1:50,000 or 1:10. That means one part on the map will represent 100 parts on the ground, or one part will represent 500 parts, or one part will represent 50,000 parts as per the case. So this is called the scale, that each point on the paper or the map that represents the corresponding point on the ground or the field. This is your scale. Now the difference between a map and a scale, and a plan rather, lies in the scale. If the scale is too small, then it is a map, and if the scale is large, then we call it as plan. You might have heard about plan of a building, or a plan of a farm, or plan of a pond. Here we require more precise work, more precision is required, more detailing is required. Here we take the scale as large. Say 1 centimeter represents maybe 1 or 2 meter on the ground, or 5 meter or 10 meter on the ground. So we want more detailing about that particular point. Such type of map is called a plan. And if we have to survey a wider area, our outreach is large, we have to survey a large area, then we have to go for smaller scale. Say 1:10,000, 1:20,000, 1:50,000. The maps which are available, or the topographic maps which are available from Geographical Survey of India, or the maps are available in 1:50,000. That means one part on the map will represent 50,000 part on the ground. That in scale, in other words, it means 1 centimeter will represent 50,000 centimeter, or 1 centimeter is 500 meter. So such type of differentiation is there between a plan and a map. In a plan we get the horizontal distance. The horizontal distance is represented in a plan or a map. The value of a map or a plan of a map is highly enhanced if we are able to represent both horizontal distance as well as vertical distance, and this horizontal distance as well as the vertical distance is represented through a topographic map. Here we can find out the different features, objects, roads, rivers, nalas, culverts. All features are there in the topographic map, and also we can find out the slope of the area. We can find out what elevation a particular point in the map is. Such information we get from a topographic map. And where do you get this topographic map? These topographic maps are available in Survey of India offices, because each nook and corner of the country, rather the world, is mapped. So nobody is anymore mapping the world. Just they are doing is increasing the scale. Earlier it was 1:50,000. Now they are going for larger scale, 1:25,000, so that the visibility is increased. So in such type of map, you can have for a wider area you have to get the map from the Survey of India office. For conducting a small survey of a field or a plot or agriculture field, you can do it yourself by instrument called dumpy level, by finding the levels of different points. Here if you see this topographic map, other than this vertical interval and horizontal interval, there are many other features, like one railway line is going here, roads can be seen, even the rivers or rivulets can be seen. And most importantly, the horizontal distance would be the scale of the map. Whatever scale is taken, that is the horizontal distance. Say it's 1 centimeter represents 100 meters. That means 1 centimeter on the map will represent 100 centimeter on the ground. And most importantly, how the vertical intervals are depicted on a contour map. What is vertical interval? Say there's a slopy land, there would be one elevation here, other elevation would be here. What does elevation means? The height of any object above mean sea level. If you see, go to Ranchi railway station, there it is written 565 meter above mean sea level. That means that particular point is 565 meter above the sea level, mean sea level. Similarly, that elevation you have to find out, and difference between this is your horizontal distance, and the elevation between this point and this point, that is your vertical distance. So these vertical distances are represented on a contour map or a topographic map through contour lines. These are the contour lines. And here these are more densely, loop is very dense, that means it is very hilly terrain. So these contour lines are very closely separated. That means the point, we will understand it in the properties of contour line. And each contour line, every will have will be there will be a value. Say here the value is 400, here it is 500. Generally for a larger survey, the contour interval is taken as 10 or 20. In Survey of India maps, you will have contour interval as 20 meters. More the extensive the survey is, the more will be the contour interval. If you have to do the contour mapping of a small area, small field, small agricultural land, then the contour interval can be 1 meter, 0.5 meter. There you will have more detailing about the area. Since we have to do it in a holistic way, so we take contour interval large. So wherever, see, these contours are very close to each other. That means if it is if it is taken at contour interval of 10, that means these two places are very close. This represents a hill. That means at every 10 meter interval there are lines. That is, and here you see this contour line here, these are far apart. That means this is more or less a flatter surface. If two contour lines are separated with large distance, that means it is a flat land. So this is a topographic map. Similarly, contour maps generally, these features won't be there, like where the culvert is, prominent objects or places, roads would not be there. Only the horizontal interval as per the scale that we have taken, and the vertical interval. These lines represents the vertical distances. Each line will have a value. This represents the entire contour. It represents a certain figure on the 3D. Now exactly what are contours? Contours by definition are imaginary lines which joins points of equal elevation. That means, and the line which we draw on the map finding the equal elevation, that we call it as a contour line. Supposingly this is a small hillock, right? If we have to represent this hill on a piece of paper, what we have to do is, first of all, we have to decide a scale on which we have to work, horizontal scale. Then again the vertical scale, at what vertical interval we should be representing each contours. Once this horizontal as well as vertical scale is fixed, then this 3D object can be represented on a piece of paper using a certain scale, converted into 2D. The 2D image of this hillock will come as like this. Since this is a mountain, it will have a periphery all around it. What we do is, we from the bottom of the foothill of the hill, we start the leveling work and find levels at different points. Once the levels at different points are calculated, found out through dumpy level, then we select a certain whole number contour intervals. Say this ranges from say 1000 to 1500. So it could be 1520, it could be 1521 also at various places. But for easy understanding, we'll take the whole number, so that but by a simple glimpse of it, we can understand, oh, this is the terrain of the area, this is the things that we have to do in this contour. So we have selected at 1100, 1200, 1300 and 1400 contours will at 100 meter contour interval we draw the contour line. So we find the places where the elevations are exactly 1100 along this hillock. Along the hillock means it would be both sided, it would be somewhat spherical or hemispherical or circular. So we will find out the points of elevation which is equals to 1100. Similarly, at 100 meter and at 1200 it will be like, and this 1100 will be represented through the outer line. Similarly, 1200 would be like this, 1300, 1400, 1500. So these contour line are forming a loop with higher values inside. That means it is a hillock. Without going to the field, if we see the map of it, we can understand this is a hilly terrain. So this is how a contour topographic map works. Same example, it is more clearer here. Here what we have done is first you have to fix a contour interval, and after fixing the contour interval along if you decide the contour interval, at each interval you draw the contour lines, that is the line joining points of same elevation. These are the elevations for this map. And the more prominent feature of contour lines or topographic map is at every 5 consecutive contours you make the line contour lines more darker, so that for easy identification of the contour value. Each contour will have a certain value. Here it is, see, 100, 200, 300 like this, and in between this dark line there are many more contours depending upon the contour interval that you have taken. From this example we can more clearly understand. This is something which you have to visualize. On this platform I am trying to make it more pictorial so that you can visualize the things in a 3D figure. See, this is a small hill, and its elevation may vary from 300 meter to say 400 meter, and we are supposed to make contours with contour interval of 100 meters. So what we do at the base where the elevation, each point where elevation is 100 meters, we join those lines, then we get a figure like this. Since it is a circular, it's a mountain hillock, it would be the elevation would be all around. So its figure, the 100 meter interval, your elevation will be represented like this. At 200 meter it will be represented like this, 300 like this, 400 like this. See, what you see here is where the slope is less steeper, the distance between the contours are comparatively larger than places where there is steep slope like this one. Here you see the distance is very small. What does it implies is, if steeper the slope, lesser will be your distance between two successive contours. This is the contour of this hill will be represented through this loop with values there. Similarly, a depression, say a depression or what do you call it, a pond. Here also we can draw the contour lines, but the contour map of a hill and a depression would look similar, because it will have closed loops according to the elevation. See, here we are doing more precise work because it is a small area, it's a small lake, or here we are making contour with contour interval of 1 meter, because the contour interval is, this is 100, this is 99, 98. So at 100 along the periphery of the lake or the pond, we have the contour 100 like this, 99 like this, 98 like this. So what I want to show here is the contour of a hill as well as a depression will look similar, but the difference being, if the higher value of elevation is inside the loop, then it is a hill. If the lower values are inside the loop or the higher values are outside, then it is a depression. And there are certain common contour intervals. There is something called contour interval and horizontal interval. Contour interval is interval between two consecutive contours. In this case it is 100, and in this case it is 199. It is 1 meters. So the commonly used contour intervals are 0.2 to 0.5 for very small precise leveling work like of a building or an estate. It can be 0.5 to 2 meters for town planning or reservoir planning. It could be 5 meters, 10 meters, 20 meters or 50 meters for large scale surveying, like that of topographic survey. For agriculture field survey, it can be 5 meters or 10 meters. And there is something called horizontal interval. We have learned that vertical interval is distance between two successive contours, that is the difference in elevation between 2 points, that is represented through vertical interval. The horizontal equivalent to it is the actual scale of the map. Say this is the map. You are making this contour map with a certain scale, say 1:100 meter, 1:20 meter. That is not talking about the vertical distance. The horizontal distance would be how much one particular point on the map represent corresponding distance on the ground. In this case, the horizontal distance would be, say, from this point to this point. The vertical interval is 1, because we are taking contours at 1 meter interval. But the horizontal equivalent would be the actual scale of the map. If you say scale of the map is 1:100 centimeter, then if it is 1 centimeter, then it would be 100 meter on the ground. So that is all about horizontal equivalent. There are certain characteristics which are associated with contour lines. First characteristic is two contour lines. The first characteristic is all points on a contour map will have same elevation. That is what the definition says as well. Every point, each point on the contour line represent the same elevation. Second is two contour lines will tell us, the observation of a contour line will tell us whether a land is flat, hilly, steep or uniformly sloped, depending upon the distance between two successive contours. If they are close together, then it is a steep land. If it is wide apart, that means it is a rather flatter land. If it has a certain gentle slope, then it will have certain uniformity in the lines. Like in this case of this figure, there is gentle slope, it is sloping gently. Third property is like uniformly spaced area will have a uniformly spaced contour lines, and plain surface or a terrace like surface, stepped area will have plain parallel lines. And this is very important. Number 5, a series of closely running contour lines, if it forms a loop with higher value inside, then it represents a hill. And if closely run contour lines with lower value inside, then it is a depression. Like in this figure, this is a depression. The lowest point here, the lowest point contour is inside the loop, and the highest point, which is at the ground level, its contour is outside the loop. This is another property of contour lines. And again, two contour lines never intersect each other. Contour lines will either end in itself forming a loop, or it will end in itself within or outside the limits of the map. Say in this case, this contour, say what is the value I cannot see here, this is it's ending itself. This contour, this is going out of the map, but at some point outside the map it will go and join, but it will never intersect two contour lines of different value will never intersect each other. But there is one exception in case of overhanging cliff. Cliff, the cliff is a kind of, we call it chattan, which is overhanging. There it may touch each other or it may intersect. That's a very rarest of the rare case. Cliff mountaineering and such kind of thing, the cliffs are there, but in normal cases it will not intersect each other. Now coming to the uses of contour lines, there are general uses, like contour lines are mostly used in civil engineering. Contour generally it's a earth science subject, geological subject or civil engineering subject, but its uses are wide. It can be used in agriculture, it can be used in civil engineering, in many other places, walks of life you can use it. Contour lines are very effectively used for the construction of selecting the site of road, railway track, and even culverts and dams, and also used very much in military mapping, like where should be the military road be going, which terrain it should be going, where should be the placement of bridges, such type of thing. Mountaineering also it's very important, where there cliffs are there, where there is very high steep slopes, such type of uses are there, generally it's used. And also it will tell whether, by seeing a careful observation of contour, we can say whether the terrain is flat, undulating or hilly. And also used for land development works. For agriculture use, is very much used in watershed delineation or catchment area delineation. Watershed is an area from where rainfall runoff takes place and joins a single point, joins a river or a stream or a pond. The entire area is called a watershed area, which we will learn later, of course. And this is used for delineation of watershed. We will do it in the practical class, how to delineate a watershed and how to find the area of that watershed by the use of topographic map. Second is for any drainage and irrigation project, from where the irrigation channel will be going, from where the drainage channel will be going. The topographic map or contour study will tell us which is the lowest elevation point where we have to place the irrigation channel or the drainage channel. It also used for cost estimation and calculation of the earthwork, volume of earthwork. Say suppose pond is dug, so how much volume of earthwork is taken, what is the volume of that pond, how much water या मिट्टी कितना निकाला गया उसमें से, so that we can find out through this contour maps. And it's very important in estimate. There are many rules like trapezoidal Simpson rule which are used for calculation of such kind of work. And for most importantly, conservation structures like bunds and terraces. We are talking about contour bunds, terraces, contour farming. For locating such type of structures, it's useful, very useful. And also we can find out the capacity of a reservoir. What is the total capacity of reservoir based upon the contour map. So this is a brief introduction of what contour actually are. And for seeing a topographic map or working with it, we will go to the classroom and see. Actually, we will take one topographic map and we'll study how the contour maps are moving, what are the prominent places and what are the different signs, and also we'll try to trace a watershed area and find its total area.